We trust AI to be our digital guardian, right? But what if that guardian has a massive hidden blind spot? Today, we're going to dive into a pretty critical vulnerability that attackers are learning to exploit. And the crazy part is, they're not breaking the code. They're corrupting the AI from the inside out. Okay, so to really get a handle on this threat, we first need to understand why AI became so darn important for our digital safety in the first place. I mean, in this constant battle against cyber threats, the old ways, they just couldn't keep up. So now we rely on something a whole lot smarter. But this brings up a really unsettling question. What if the very systems we built to protect us could be tricked into trusting the enemy? Not by hacking their code, but by messing with their education. And this isn't some sci-fi movie plot. It's a real and growing threat. And it all starts with the data we use to train them.
We absolutely rely on these machine learning models as our frontline defense against new, unseen digital threats. See, unlike old-school antivirus software that's just looking for known virus signatures, ML can actually spot brand new, what they call zero-day malware, just by recognizing malicious patterns. And look, it's not just in cybersecurity. This is the same tech that powers self-driving cars, our voice assistants, and even decides who gets a loan. It is woven into the most critical parts of our lives.
So if you wanted to sabotage one of these AI guardians, how would you even do it? Well, the answer is surprisingly simple, and honestly, it's kind of terrifying. You don't have to break down the door. You just poison its education right from the start. This whole concept is called data poisoning. It's where an attacker deliberately feeds the AI bad information while it's still learning. The goal? Well, it's either to create a secret backdoor they can use later, or, as we're going to see, to just mess with the AI's performance so much that it can no longer tell a good guy from a bad guy. And the process is just deceptively simple. I mean, a healthy machine learning pipeline takes in good data and spits out a reliable model. But an attacker can sneak in at just one point, injecting that poisoned data right into the training set. And that one little action corrupts the entire process, turning a trusted guardian into a total liability. Okay, so the most basic version of this is the label flip attack. And the analogy for it is just perfect. Imagine you're teaching a student to identify cats and dogs. But before you give them the flashcards, you secretly swap the labels on a few. So now the card with a picture of a dog says cat. The student, in our case the AI, has no reason to doubt you, so it just learns the wrong lesson. So to see just how bad this could get, researchers ran this really straightforward experiment. First, they trained 8 different malware detectors on a totally clean, reliable data set. Then they took that same data, but this time they flipped the labels on just 10% of it, marking some malware as safe and some safe files as malware, and retrained the AIs. And finally, they cranked it all the way up to 20%, just to see how much damage this one simple trick could really do. So what was the damage? Well, the results of this simple little attack were dramatic. We're not talking about a minor glitch here. This was a fundamental breakdown of the AI's ability to do its job. Let's take a look at the before picture. This chart you're looking at, it's called a confusion matrix. It's basically a scorecard for the AI. And on clean data, the results are incredible. It correctly identified over 13,000 malware files and over 7,000 safe files, with almost no mistakes. This thing is a solid, reliable digital guardian. Now, look at the after. With just 20% of its training data poisoned, that same model is completely crippled. It fails to identify over 3,000 pieces of malware that it caught easily before. And what's even worse, it now incorrectly flags over 2,000 perfectly safe files as dangerous. This AI isn't a guardian anymore. It's just confused, unreliable, and it's leaving the front door wide open. And this wasn't just a fluke with one model. The damage was consistent across a bunch of different types of AI. Their accuracy just plummeted by 15, almost 17%. I mean, think about that for a second. These are highly effective systems, trusted to be nearly perfect, and now they're failing spectacularly because of one simple trick. A 15% drop might not sound like a huge number, but in the real world, it's devastating. It means a security system that was once nearly perfect now lets roughly 1 out of every 7 malicious programs slip right through, totally undetected. That is a massive, massive security failure. But, cybersecurity is always a battlefield, and the researchers, they're not just standing still. For every new attack, a new defense gets engineered. They're developing a whole new class of defenses to teach our AI guardians to be more resilient, a little more skeptical, and ultimately, a lot smarter. It's this constant game of cat and mouse. The attacker wants to cause chaos, right? Make the AI misclassify files, reduce its confidence, maybe even let specific bad files through. But the defender, on the other side, is trying to build tougher systems that can actually certify their own predictions, find and correct those wrong labels, and spot the poisoned data before it can do any harm. One of the most powerful new defenses is this concept called certified robustness. Now, this is way more than just a general upgrade. It's a mathematical guarantee for every single prediction. It's kind of like an official stamp that says, hey, this decision is trustworthy and it will not change even if some of the training data we used was garbage. So now, modern defenses are getting way more sophisticated. It's not about building one single high wall anymore. Instead, it's like a multi-stage gauntlet of filtering, learning, and detection. Before any data can even touch the AI, it gets analyzed for poison and passed through all these different layers designed to neutralize threats before they can do any damage. And researchers are deploying a whole arsenal of really clever techniques. Randomized smoothing basically adds a bit of statistical noise to make it harder for attackers to have a predictable effect. There are clustering-based defenses that group data together to look for outliers. You know, those data points that just don't fit in, which could mean a flipped label. And they're using advanced learning that uses a small amount of trusted, clean data to help guide the AI in figuring out the rest. So this brings us to the really crucial takeaway from all of this. This problem is not solved, not by a long shot. We're in the very early stages of a constantly escalating arms race between the people building AI and the people trying to corrupt it. For every new shield the defenders build, the attackers design a sharper sword. As defenders get better at spotting random attacks, the attackers just get smarter. New methods like this Falfa attack don't just flip labels randomly. They use some pretty slick math to calculate which specific labels to flip to cause the absolute most damage. It makes their attacks faster, more efficient, and a heck of a lot harder to detect. And the reality is, we're still just scratching the surface of these vulnerabilities. As the researchers themselves point out, the community is still trying to figure out just how deep this problem goes and how to build truly tough AI that can actually withstand these kinds of sneaky attacks. Which leaves us with one final, pretty provocative thought. As we put more and more of our trust in AI to protect our money, our privacy, our safety, the integrity of the data we use to teach them becomes everything. It really forces us to ask, in this age of AI, who's training the trainers? And how can we ever really be sure they can be trusted?